Come here. Sit pretty. Sit pretty. Good boy.
Now he does it right.
Good boy. Sit pretty. Sit pretty, Aria. Good boy. That was my bunny Aria, and he was our inspiration for our final project that you can see here. Basically, we took this phenomenon of him being trained by being given a treat and mapped it to a finite state machine. So this was phase 2 of our project, and here you see that basically we start off with the bunny who's sleeping. We throw a party, he gets energized, and we can then train him. And here we can give him the command walk 3 times in order for him to learn this behavior. Then after that we can exit the train stage, go back to whatever behavior state he was in, and interact with him in other ways, such as giving him a toy to play with. After you do that, he goes to another state, which makes him bite you. If you throw away or take away the toy, he goes back to this energized, happy state. From there, you can see that if you give him the command walk, he knows that, but if you give him something like around, he has not learned that. So we decided to map this to something physical. We actually created a maze here that a bunny could theoretically traverse. Each state is represented by one of the quadrants of the maze in a different color. And the LED light, it's a little bit hard to see, actually represents the state that the bunny is in and the behavior it would produce. In order to do this, we actually used an Arduino board that's programmable, and we hooked it up to a bunch of switches and buzzers here. You can see that basically we're building this maze out of cardboard, doing all the wiring for switches and buzzers. Our project consists of a lot of hooking wires together and learning a lot about the electrical circuit part of the model. In order to represent the training, we've set up some switches in our maze, such as this one that's hooked up to the buzzer, which is all hooked up to a battery over here. So that when you press the buzzer, or when you go over the switch and you press the switch, the buzzer goes off. This is our remote control robot, Jill, and whenever she goes over this switch right here, you'll hear the buzzer go off. And that's letting her know that she's going the wrong way. So basically, our bunny, Jill, starts off at the start stage in the black and then goes towards the buzzer. That switches the state, the light turns red, and you hear the buzzer go off. Sometimes she gets stuck, so we just have to help her a little bit. But once she goes over the next switch, it will trigger a state change. The bunny's behavior will change, and the LED light will turn to a yellow color. So basically our bunny here is just traversing through the maze, and each little switch that it goes over, it completes the circuit, and that goes back to our Arduino board and lets it know that a certain input has been pressed, and then it changes the lights on the LED strip. So each of the 8 quadrants is directly mapped to one of the states in our FSM. And the buzzers, as you're about to see here, basically shows that the bunny is going in the wrong direction and serves as a training tool. So here we see what would have happened if the bunny had decided to go into the orange quadrant instead of the pink one. Again, change in LED, buzzer to let it know it's going the wrong way, it's hitting to a dead end. And here we see what would happen if it decided to go in the third direction, which is towards the green quadrant and then towards the light blue one, finally heading towards the orange one and getting close to its exit. This project basically would be similar to Primo IO by showing that there's a physical model that you can interact with, guiding this rabbit that we have through a maze and mapping it directly to computer science theory, like a finite state machine. And here you see that Jill finally makes it to the end, and our LED has a rainbow flashing through it.